Hi friends, this is Alampal. Today in aerospace teachers I am going to give you a small introduction about the design of a reviet joint. And my topic is design of reviet joint in concept video. And types of reviet joints. Types of reviet joints are there are lap joint, butt joint. In butt joint there are single cover butt joint and double cover butt joint. In butt joint there are two types. Butt joint with single cover butt joint with double cover butt joint. And important terms used in the reviet joints are pitch, back pitch EB, and margin or marginal pitch M. There are used important terms in the reviet joints. You can able to observe that a diagram lap joint where plates to be in joint, and butt joint there are one plate over the another plate. And we can able to observe that figure supporting the plates and rivets and plates to be joined, and in which we can able to observe that single riveted lap joint and double riveted lap joint. In single riveted lap joint they are in the same in a straight line. They are taken as M. Double riveted lap joint is also known as the chain riveting. The distance between them is PB. And the failures of a rivet joints are shearing of the rivet, crushing of a plate or a rivet, tearing of a plate. This is known as the failure of a rivet joints. And the shear of a failure. This is a failure of a rivet joint. And we are able to identify that there are two types of lap joints. Two types of rivet joints. There are single riveted lap joint and double riveted lap joint. And also they are also considered as a butt joint. Then we can able to observe the figure as shown on the screen. And the failure of the rivet joints are shearing of the rivet, crushing of the plate or rivet, tearing of the plate, in which by producing some tension on the rivet, it may able to crush or tearing based upon their nature. And shearing of a rivet, in which shearing of a rivet in the lap joint and shearing of a rivet in single cover butt joint, where those are known as single riveted lap joint. And crushing of the plate or a rivet, when we are able to crush one over the other, we can able to find that the small displacement as shown in the figure. And tearing of the plate, we can able to observe that the tearing of the plate where the total length is a P and the distance we can able to calculate as P minus D. And we also know that there is a design of a plate in the tearing of the plate. And we are able to know about some basic equations. We know that shearing area where AS is pi by 4 into d square, where 2 is in a single shear, in which double shear, in theoretical in which double shear, where we can able to can multiply it as 2. And further simplification we are able to get in double shear according to the Indian boiler regulations, where 1.875. And total there are about 3 shearing areas as shown, where AS is equal to pi by 4 into d square and 2 into pi by 4 into d square, where 1.87 into pi by 4 into d square, in which double shear occurred into the boiler regulations, and 2 into pi by 4 into d square is known as the double shear in a critical manner. And shear resistance are still required to a shear of a rivet per inch length, where PS equals to n into pi by 4 into d square into pi, or in a single shear where is known as PS, and vertical in double shear n into 2 into pi by 4 into d square into r. It is in the theoretical of a double shear. Those are the shears in single shear and the theoretical double shear. And once here we can able to observe that shear resistance are pulled required to a shear of a rivet per pitch length. P is equals to n into pi by 4 into d square into r, where n into 2 into pi by 4 into d square into r is known as in single shear or theoretical shear. Thickness. The resistance offered by a reviet by crushing is known as the crushing resistance or crushing strength or bearing load of a reviet. Let P equals to diameter of a reviet hole, T equals to thickness of the plate, sigma C equals to safe permissible crushing stress for a reviet plate material, and N equals to number of rivets per pitch when under crushing. Know that crushing area per rivet, projected area per rivet, where AC equals to D into T and total crush area equals to N into T into theta, N into D into T, where N is known as the number of rivets and D is known as the diameter of a rivet hole, and where P is known as thickness of a plate, and the crushing resistance are required to crush the rivet, where per rivet pinch length equals to PC equals to N into D into T into sigma C. This is about injection. This is about a crushing resistance or bearing value, and overall the crushing resistance or pull required to crush is known as N into D into T into sigma C, where N is the number of rivets, D is the diameter of the rivet hole, and T is the thickness of the plate, and sigma C is the permissible crushing stress for a required rivet or a plate material, and the resistance offered by the plate against the tearing is known as the tearing resistance or tearing strength or tearing value, in which tearing will be occurred when we are producing certain amount of a tensile strength in between the plate. We are able to observe that there is a tearing resistance or a tearing value by producing some tension on it, where let P is known as the pitch of the rivet and D is known as the diameter of the rivet hole, and T is the thickness of the plate, and sigma T is the permissibility of the thickness of the strength for a plate material. And we know that the tearing area per pitch length AT equals to P minus T into T, where P is the pitch of the rivet, T is the diameter of the rivet hole, and T is the thickness of the rivet, and tearing resistance or pull required to the tear of the plate per pitch length, where PT equals to AT into sigma T equals to P minus T into T into sigma T, where T is known as the thickness and sigma T is known as the permissible tensile stress. And overall the basic formula of the tearing resistance or a tearing strength or a tearing value we can able to say that PT equals to AT into sigma T equals to P minus D into T into sigma T. Thank you.